1/2, or they have to figure out how many feet are in a mile and write it in feet or whatever. You can do whatever you want there. If you left it as 1/2, that means your units are in miles. If you did half of 5,280, then your units were in feet. If you figured out how many yards were in 5,280, then did half of that, your units would have been in yards. It wouldn't have mattered. It's one of those things. As long as you keep your unit stuff straight, you would have been fine. So if you want, I can give you some of my answers. You want to make sure you got them right. You want to see that okay? So let's see here. We did 1, 2, and 3 in class. 4 we kind of did in, the day before with the sharks. Shark in the water. 5 technically now, when you do this, you should get 91.3-ish, something. Bless you. On 6, and just let me know if you don't get any of these. We'll walk through it. 47.47.51. Jack and Jill went up the hill to fetch a pail of water. They fell down both sides of the hill, and they were this far apart. That's a pretty far distance. Yep. As you wish. No. Because he fell down the mountain. Yeah. 8, I got 184.35. That's just a quick law of science. What about the flagpole? Does that make sense? Yes. How the flagpole was leaning and it came down and flew across. You had to get, when you draw that, you had the flagpole that was leaning because there's your flag. It's very windy, or the guide wire was pulling it really tight. What's that? Thanks. It's forcing you to figure out this one first. When you find that one, you get what, 75/15, I believe. And then you have to figure out this angle up here, so you subtract out from 180. Did you catch that? That's the idea. A lot of times with some of these sine cosine style problems, they're going to ask you not just to figure out what's going on, but they might take it that one extra step with, in this case, what's the angle that the flagpole makes with the guide wire. You guys know what a guide wire is, right? Have you ever set up a tent? No. Have you ever seen a tent? Have you ever seen a tent? Okay. So when you have a tent, you should be attentive to what's going on. So there's your standard boring dome tent. Here's your door. Okay. If I drew it 3 dimension, then it would be an igloo. Anyway, so then a lot of times you have like a rain shield. Okay. These things are tied off. There might be a rope here. And then you have like this little wire that pulls it down. It's kind of the same idea of a guide wire. A guide wire is generally used when you are pulling a rope up to something. You take a wire, and the wire's on a pulley, and it goes through, and then you just go to a circus when they're setting up, and you'll see it. Road trip! Yeah. Aren't you guys just traveling circus as yourselves, walking through the hallway? Well, you're not funny like that. Want to make a clown or make you laugh? Goodfellas? Please. I'm banking on you seeing Goodfellas, and you failed me on this one. You guys have not seen Goodfellas yet? Put it on your list of things. Do I make you laugh? Am I funny like a clown? See where I'm going? I'm just not gonna finish out the rest of those lines, but bless you. All right, so we're good on. We did okay on those then.
Yeah.
All right, good. Now, thanks. That's why I have a candle. I'm too old to sleep in this bed. I'm not happy. Anyway, when we go back through the stuff that we've looked at in this first couple of weeks of trig stuff, we had basically works out to be 3 sections. Oh, yes, we do. So when we started talking about our trig stuff, we basically had technically 3 sections. And these 3 sections were kind of a mixture of everything that you guys have done in geometry last year. If I'm not mistaken, there were only 2 new things that we did this time around. One of the new things that we did in 13.1 looked like this. If I said that the secant of theta was 17 over 15, then I'd ask you what is the tangent of theta. All right, that was one of the new things because when we in 13.1, it was all SOHCAHTOA, special right triangles, angles of elevation, angles of depression. But then we started talking about the inverse trig functions. And the inverse trig functions, remember we have sine is opposite hypotenuse, cosine is adjacent hypotenuse, and then tangent was opposite adjacent. I apologize for not putting the theta or angle or whatever in there. A lot of times I don't because I forget. But anyway, we know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent's opposite over adjacent. That was that good old-fashioned SOHCAHTOA. What was new to us this year was when we started talking about what are called the reciprocal trig identities. Now the reciprocals just means that you flip them. Okay? So you had cosecant, secant, and cotangent. Now, cotangent's easy to figure out which one it goes with. You might be able to figure that one out. It goes with tangent. But the thing that's weird is that cosecant goes with sine. Okay? Sine and cosecant are inverses of one another. So cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And then cotangent was adjacent over opposite. And starting next week, we'll spend more time using these values than we did this time around because we don't usually find theta values using calculators to get secants, cosecants, and cotangents. We'll use those when we start talking about our special right triangles and working off the unit circle. It becomes a little bit more clear as far as those values are concerned. Plus, eventually, what's the sine of 30? Very good. I didn't change the answer. Change the question. But you remember. So, if I'm looking at the idea that I have, whenever I write out secant of theta, or if I say, hey, cotangent of theta is this, one thing that you can go ahead and assume is that this is dealing with right triangles, because they have to. Okay. So if you have secant of theta is 17 over 15, that means that it is, well, what's the 17 playing the role of? And 15 is playing the role of an adjacent. So we draw a right triangle, place theta. It doesn't matter if I put theta at the bottom or theta at the top. It doesn't matter because it's, remember, like I always say, trig is all about perspective. It's all about wherever you place theta, it has specific values. So that gives me 17 and 15 And I think I asked what was tangent going to be. Well, how do I figure out what that is? Yeah, let's use Pythagorean theorem. Okay. So using Pythagorean theorem, we take 17 squared, subtract 15 squared, you get 8. Very good. It is. You'll see triples a lot with these because they try not to make it too overly complicated, to be honest with you. So now that gives you somebody step on a duck? I need to do that with better. That's from a movie, in case you didn't know. Oh, somebody step on a duck? Rodney Dangerfield?
Oh. Yeah, that's.
Yeah.
Yeah, no, thanks for that. Is that where you got that from?
Somebody step on a duck?
No. Did you get that? Okay, got it.
So your tangent of this value would be 8 over 15. And go on your merry way. It's good.
I know what you're gonna do. You're gonna have the spines, all of the things off of something and then giving us.
We did problems like that. But, I mean, honestly, like I was saying, we just introduced this right now. What you'll see more problems like that next week, because next week I'm gonna do this. Don't write this down. You'll do something like that. We'll switch into that. Evaluate the 6 trig functions whose terminal side of an angle lies at -3 and 4. That's when we get into evaluating all 6 trig functions. For right now, we're not there. It's very. Well, they're big, heavy, and wood, so there's that. All right. So that was one of the first new things that we did. The rest of the 13.1 stuff, you had elevation, and angles of depression. When you have, I almost dropped that. That was a good catch.
Nice.
So when you have angles of elevation versus angle of depression, remember when you're looking at working with those. Angle of elevation is technically what we call line of sight up. Elevation is line of sight up. Angle of depression, on the other hand, is line of sight down. Remember, when you have angle of depression, your line of sight is always parallel to the ground. Even if you have elevation and you're above the ground, you're still parallel to the ground. Like my eyes are, if I'm looking straight ahead, I'm still parallel to the ground there, so it still works. What happens here is you have 2 parallel lines cut by a transversal, and this angle here is also your angle of depression, but these 2 guys are always congruent. Angle of depression, line of sight looking down, is the exact same angle of elevation looking up. Angle of depression is the same thing as angle of elevation. It just spins from the outside of the triangle to the inside of the triangle. And that was one of the big things you guys did a lot of last year. We didn't do a ton of problems with those. I think we did, 5, 6 of them maybe. I think I had the one worksheet with something too crazy. But we still worked through those a lot. It was a lot of trig functions. It was, basic SOHCAHTOA stuff in there. So we had that. Speaking of SOHCAHTOA. Solving right triangles. When you solve right triangles, you use SOHCAHTOA. There you go. That was easy. I think pretty much you guys know how to press buttons correctly. The only thing that you have to really make sure you have to worry about is that your calculator is in what mode? Degree mode. Okay. I don't think physics you have to worry. I don't think they switch you out of degrees, do they? What? What's wrong? Hey, you have a chem test. Did you forget about your chem test? Oh, degree, yeah, chemistry, there's no degrees in chemistry unless you get a degree in chemistry. Yeah, periodic tables on those. That's one of the other reasons why they don't really let you guys use those calculators. What else? Oh, we did a lot of specials, but we didn't do a lot of those. We do more of that next time around. And after that, really the only other two things that we did were law of sines. And then law of cosines. And then you had all the versions of it. Now, the new thing that was with the law of sines this year was the idea that you could possibly have no triangle or two triangles. The no triangle came into play when we had, if you're given an angle, and let's say it was an obtuse angle, but the side across from it was shorter than the other side. That meant it was either a typo or there was no triangle. So we just said there was no triangle. But the other part was when you had what was called that ambiguous case. And when you have the ambiguous case is when you could possibly have two triangles. So when you're going through those, remember, one of these. I don't remember which one I made was ambiguous. Cosine.